Okay, so that's 2014 NCEA paper. So you've got the x minus 2 is a factor of this equation. You want to find the p-value. When it's a factor of this equation, that's mean 2, because it's x minus 2 equals 0. So that's mean x equal to, if I substitute instead of x2, it should give me 0 as an answer. And that's what I will get to solve the equation and to solve the value of p equals 0. If I solve that, I'll get p is half. Okay. Now the next one here, I've got u, and I need to find u to the power of 4. Now, as we said, we can't expand this 4 times, so it's easier to change this into a polar format. To change it into the polar format, you're going to write r value, which is 3 square plus 3 square, and that's give me 9 plus 9, which is 18. 9 plus 9, which is negative 18. So to find, and then I will have to find the theta. Now the theta is cosine theta should give me 3 over square root of 18. So cosine inverse to theta, and give me the theta as negative pi over 4. Now I can write u in a polar format, so it's square root of 18 cis negative pi over 4 to the power of 4, and that's mean negative 18 to the power of 4. This is to the power of half, square root of negative 18, so that's half. Half times 4 is 2, that's why I'll end up with 18 square cis 4 times negative pi over 4, and that's why you will end up with the final answer 324 cis negative pi over 4. Now the next equation is solve the equation here. Again, I've got a square root, so I need to rearrange in square. So I will have x minus 3 equals square root of 33 minus 4x. Square both sides, so I'll end up with x minus 3 all square equal 33 minus 4x. Expand, I've got 6 square minus 6x plus 9 minus 33 plus 4x equals 0. Now rearrange, I've got x square minus 2x minus 24 equals 0. So that's giving me either x, if I expand factorize, it's x equal negative 4. Now because I've got 2 solutions and I will have one value of x in here, so I need to check those 2 solutions. Now if I check x is equal to 6, I got 6 equals square root of 9 plus 3, and that's true, because that's give me square root of 9, 3 plus 3 is 6. Now if I try x equal to negative 4, I will end up with negative 4 equals square root of 49 plus 3, and that's not right, because square root of 49 is 7, 7 plus 3 is 10, 10 is not equal to negative 4, so that's false. So the solution is equal x equal to 6. You must do this step, the checking. Okay, next question. So you've got solve z to the power of 4 when k is a real number. So again, you'll write it in a polar form, so you can tell that you've only have the imaginary part in here, and the imaginary part is negative 4k square I. which means that you will find the r value is 4ki, k square, and the negative I is where you're going to find your theta. So you need to find a theta that the sine of that theta is -1, but the cosine for the theta is 0, and that would be, the theta would be -pi/2, or theta is -90. So it's up to you which one you would use. I always would like to work with 90, sorry, the degrees. Alright, so next bit here. Okay, so the next bit is you will say z equal the 4√4k squared for the r cis -90 plus 360k over 4. Now you're going to find the different k values. So you can use the table, graphic calculator table, as we've done it in a class. So you've got the first value is z, that's -180 over 4. And then the next value, so you need to have 4 different values. Cis. So basically you would go here, would go to table, and in the table I would write this exactly as it is. I will write -90, sorry, -90 plus 360. Instead of k, I would write x over 4, and I will make sure the range, do have enough range, and the set is 1. So now if I press table, I need to look for the values that's between -8, -180 and 180. Okay, so I've got the first one in here, so I'm just going to write it again. -112 when k is -1. The next one is -22.5 when k is 0. I'll keep going. Z3 is cis for 67.5 when k is 1. And the last one, Z4, 2k cis for 157.5 when k is 2. Now you can see the next one will be over 180. So those are your 4 different answers. Okay, now the next question. Find the equation of the loci for this one here. So you've got the length of this is equal to the length of that. Remember the z, so we're going to write it as general x, so it's x plus yi minus 1 plus 2i equal x plus yi plus 1. Okay, and then you rewrite, so you've got the real parts together, the imaginary parts together. So you've got x minus 1 plus y plus 2, I equal x plus 1 plus yi. And now you're going to find the length of that. So you've got the square root of x minus 1 square plus y plus 2 square equal square root of x plus 1 square plus y square. I've got both square roots, so I'm going to square it. So I've got x minus y 2 square equal x plus 1 square plus y square. Now I expand normally and try to simplify. So I've got x squared plus 2x plus 1 plus y squared plus 4y plus 4 equal x squared plus 2x plus 1 plus y squared. So I've got those x's will simplify, the y's will simplify. positive one with the positive one will be simplified, so I will end up with negative 2x plus 4y plus 4 equals 0. No, equal, positive 2x. Rearrange or try to write it as a main linear equation mx plus c, so I can read the gradient and the y-intercept. So I'm just going to have y equal, taking this to this side here, become 4x, and this negative 4 divide by 4. That means I've got a line with gradient equal 1 and y-intercept equal negative 1, because if I simplify that I'll end up with x minus 1. And that's it. Okay, next question. Again, solution, so you need to write it as a quadratic formula. So it's negative b, that's giving me 4. B squared is 16 minus 4 times a times b, so that's 4 times 16, and that give you 4 times 16. It's too late, I don't want to think about it. 4 times 16, 64 over 2. And then I got 16 minus 64, negative 48, so I end up with, that's 2 will be simplified, 4 will be simplified with this 2, so I'll end up with 2 only, plus and minus negative 48 over 2, and because it's negative 48 over 2, so I know I have to have I in there, because I can't find the square root of a negative number. So I've got 2 plus and minus negative 48 comes from 4 times 12. So I've got 4 can come out from the square root, and then left is 12i over 2. This 2 simplify, so the final answer is 2 plus square root of 12i. That's my final answer, and this is in the format that's required. Now, next question. Now, given that this is the equation you want to find to the power of 4, so you just basically 2 to the power of 4, and you need to give your answer in a plus b. So you need to find that first the answer in this format. So I will have 2 to the power of 4, that's 16, cis 4 pi over 3, because I multiply the power by the angles by 4. So then remember, this one can be written as 16 cosine 4 pi over 3 plus sine 4 pi over 3i. That's what cis mean. Now we're going to find the cosine of 4 pi over 3. So my angle is, my calculator in degrees, so I'm going to use 4 times 180 divide by 3, so it's 240. So cosine 240 is negative half, and sine 240, so it's negative 0.87i. Then I multiply by 16, so I'll end up with negative 13.86i, and that's times 16, it's negative 8. So that's my final answer. Alright, so next question is 2 minus 3i is a solution of this, where a is a real number. Find the value of a and the other two solutions. Now, because I've got, as I said, there is no sign of complex components in the equation that's been given. So that's why I will have to, that means the first solution is 3i, the next one must be the conjugate of that. Okay, and the third one, maybe I'll call it a, whatever. And then in here, then I will rewrite it as factors. So I will have 3w. So I've got the w minus 2 minus the 3i, and the other one is w minus 2 plus 3i. Now if you expand this one here, you will end up with w squared minus 4w plus 13. Okay, so it's plus 13, and now this one here is your equation. Then you will multiply it by the other factor, which is kw plus a, and that should give me this equation. Now because of that one here, if you work it out and if you multiply and you will compare it with that equation, so if I expand it in here, I will get k w cubed plus a w squared minus 4kw squared minus 4aw plus 13a equals 0. Now if you compare this with this equation, that means k is equal to 3 because it's the coefficient of w cubed. Now the coefficient of w square is negative 14, so if I look into that means it's a minus 4k should give me negative 14. Now I know k is 3, so it's a minus 12 give me negative 14, and that gives me a equal negative 2. Now if a is equal negative 2, you work it out and then you will say, alright, so that the equation, it's 4 times a is the w, the formula of the w in here, so the coefficient of the w. Alright, so we've multiplied, I'm just double checking the expanding. I've got this, okay, so I've missed this bit here, so I have another term is 30 plus 13kw. Okay, now a, the one that I'm trying is the coefficient of w, that's why I'll work out that's negative 4a plus 13k it's equal to big A, which is the coefficient of the w. Now I know the a and I know the k now, and if I multiply them in the calculator, that should give me 47. Now to work out the other factor, if I've multiplied everything, so to work out the other factor is a, this is the first part of the equation, find the value of a. Now the other two solutions, we already know that one of the solutions is the conjugate. Now the other solution is kw plus a, so that's giving me w equal negative a over k. To work it out is 2 over 3. So that's my other solution. Okay, so we've got this one here. Sketch the loci points. Sorry. Okay, so they ask you to sketch the loci points for this z. Well, you can sketch it straight away or you can work it out. So just as a reminder, this is x plus yi minus 3 minus 4i equal to. So we know will be a circle because we've done these type of questions before. So the circle is x minus 3 square plus y minus 4 square is equal to. So you've got a circle with a center 3 and 4. So you've got your center 3 in the x, 4 in the y, so that's your center, and the radius is 2, so it's 1, 2. Okay, so it's up to here, and then up to here, and up to here, and up to that one, and then just, sorry, my graph is always messy. Alright, so that's sketching. What's the maximum value of our real z? So the real z is this one here, that's the real z. Maximum value is 5. Okay, so now we'll just continue to the next question. Next question is the complex number of z is given by this, where p and q are real. Given thus the argument, show that p minus 2q is equal 0. Now, your first step all the time is just because it's has a complex number in the denominator, you would multiply by the conjugate. That's your first step all the time. So it's p minus qi and p minus qi. Now if you expand, you will end up with p minus qi plus 3pi plus 3q over p square plus q square. Now you conjoin the real parts together and the imaginary parts together, so it gets real, and you've got plus 3 pi minus qi over p square plus q square. Right. Now, because I've got the arguments, it's pi over 4. Now, if you go 10 to this argument, here is 1, which means that the real parts is equal to the imaginary parts. It's always when you have pi over 4, which is 45 degrees. So because it's pi over 4, which is equal to 45 degrees, it means the tan for that is 1, which means real equal imaginary. And that's why they always use that 45. So it's a quite common, it comes in the questions. Which means that the real parts in here is equal to the imaginary parts. So you've got p plus 3q over p square plus q square is equal to the real part, which is alright, and because that's the same, so you can cancel them out, you multiply by the same value, so you've got p, you've got 3p minus q, which is the imaginary parts, over the real parts, which give me 1, because that's the tan. Tan, remember the value of tan, or how we define tan? It's the imaginary part over real part is sine over cosine. So that's why we've done the imaginary over the real, which equal to 1. And that's, if you solve this equation here, you will end up with p minus 2q equals 0, and that's proven. That's the requirement in here. Okay. Final question, 2014. Expand. So you're expanding this shape here, and then you format, so it's just a normal expanding, not really anything special into it. So we've got this one here, you've got 10 minus, plus 4 square root of 3, and then minus 5 square root of 3, and then square root of 3 times square root of 3 is 3, and that's why we'll end up with negative 6 in here. 4 minus 3 square root of 3. Now I'll simplify this one here. So I've got 10 minus 6 is 4. 4 minus 5 is negative square root of 3 times 4 minus 3 square root of 3. Now expand the last bit, which is 16 minus 12 square root of 3 minus 4 square root of 3, and that's 3, so it's plus 9. Now if I simplify it further, so that'll give me 25 minus 16 square root of 3, and that's your final answer. Okay, so the next one is here. You've got similar to the questions before. You need to find 2p minus 3q. Okay, so you've got the p. The p is, looking at this one here, it's negative 1 plus 2i, and the q, the real part, is 2, the imaginary part is 3i. Now I'll substitute in this formula. So I've got 2 times negative 1 plus 2i minus 3, 2 plus 3i. And if you work it out and solve it, you will end up with r equal negative 8 minus 5i. You can use the calculator to solve those type of questions as well. And then you mark this one as negative 8 in here, and minus 5i, so somewhere here, that one. That's your r value. I'll just show you how to use the calculator for it. I'm sure all of you tried it before. So you go to option, you go to complex, and you write that as it is using the I. So this page will give you the I, which is negative 1 plus 2i, close bracket, minus 3, open bracket, 2 plus 3i, close bracket. If I equal, you can see I got the final answer straight away. So it's quite a straightforward things to do. Okay, page 8, yes, that's where we are here. Alright, for what values of p, where p is real, does this graph not intersect with the x-axis? Now when it says that it does not intersect with the x-axis, that means it does not have real values. Okay, that's what it means. So it's just another meaning. Not intersect with the x-axis mean no real roots. Okay, so when there is no real root, that means this less than 0. So you're going to substitute using this equation in here. So p squared is 16. P squared minus 4px plus, 16p squared minus 4p less than 0. You've got 4p as a common factor, so you'll end up with 4p minus 1 less than 0. So p either less than a quarter or greater than 0. So that's your final answer. Alright, now the next one here, given that z find the value of the conjugate square of that z plus 1 over square z. So it's just substituting. So the conjugate all square plus 1 over 3 plus 2i all square. And if you simplify it further, you've got 5 minus 12i plus 1 over 5 plus 12i. And then to work this one out, okay, so because I've got a conjugate in here, sorry, a complex number at the bottom, so I must multiply by the conjugate of that. Okay, and that's why we'll end up with an answer of 850 over 169 minus 2 of 2040 169i. So it's just basically you're expanding, simplifying, and that's your final answer you end up with. Now the last excellent question. So you've got 3 roots. So they say alpha, beta, and y. It's gamma. This the 3 roots of the cubic equations of this one here. Because it's the 3 roots, so you know straight away you will write it as x minus alpha, x minus beta, and x minus lambda. Then expand. So you're just gonna expand normally x, sorry, alpha and beta. That's the first one. Now I expand that one. There's no like terms in here, so I can't do anything really. So I'm gonna expand this one here with the next bit. It's quite a long expanding. It's easier when you do it by hand, so it just makes more sense for you. Alright, so I've got that square, sorry. So I'm going to expand it now, x to the power of 3 minus x square lambda. And then I'm here now, got negative beta x square minus beta lambda x. And I've got here alpha x square minus alpha lambda x, and the last one is lambda beta x minus that's all the ones with the lambda is plus because it's negative times negative, so and that's plus, sorry. Alright, where am I? So that's plus, so I've got alpha beta x and then minus alpha beta y, which is the lambda, sorry. And then I've got, I'm just gonna check the answers. Okay, so now after that you will reamend it with all the x's, the coefficient of x squares together and the y's together, the x together and the constant by itself. So you've got x to the power of 3 minus alpha plus beta plus gamma for x2, and then you've got alpha y beta y plus alpha beta for x minus alpha beta y equals 0. Now if I compare, now I will come to the main equation here. Now my main equation is this. Now the coefficient for here, when you factorize them, you will always end up with x squared. If I divide by if I divide by a, I've got b over a x squared plus c over a x plus d over a equals 0. Why I'm dividing by a? Because I need to have x cubed in here. Now when I compare the coefficients, I will have alpha plus beta plus gamma is equal b over a, because I'm comparing the x squares with the x squares. Alright, and that's where I'm comparing the two coefficients, so it's minus, sorry, that's minus because it's a minus in here. And if I compare for the x's, the coefficient of the x, I will have alpha beta plus beta gamma plus alpha gamma equals c over a. Now from here of the constant, so that's what you ask you to prove, so you prove them. For the constants, you've got this bit here and you've got d over a, so it's quite straightforward for the constant. I'm putting negative because it's a negative in the constant, and here is a positive. Alright, so the next one is proving that all of this is equal b d over a. So now if you work this one out, you will have a common factor. So if you find the common factor, which is alpha beta gamma, and then left is alpha for the first one, beta for the second one, and gamma for the last one. Now we already know alpha, beta, gamma is this one here, which is negative b over a. And we already know this one is negative d over a. Now if you multiply them, you'll end up with bd over a squared, and that's square. So it looks ugly. It's not really ugly. It's just because of the letter letters they've used. And I've finished 2014. So thank you for listening. Good luck.